Okay, welcome back, folks. So today I have decided to extend the capabilities of this sliding script. Particularly, I wanted to make it so that when you rotate the camera, it'll also slightly change the direction of the slide. So you can see that being demonstrated here. You can see, and also how drastic the turn is depends on how fast I move my camera. You can see the more drastic the turn, the more drastic the change in the camera, the more drastic the turn is. If I go slower, see that turn is not as drastic. And also I made it so you're able to rotate easier when the slope you're sliding on is steeper. And from a real life standpoint, I think that makes sense, right? Because when you're sliding on flat ground, it's harder to rotate your body. But when you slide on sloped ground like this 45-degree ramp here, it's easier to, rotate your body around. So I've also added that feature. And this also works in non-shift lock mode as well. Pretty smooth. I mean, stairs are pretty hard to slide on, but I think even then, it's decent. If you really want to work on stairs, you'd have to adjust that the airtime variable from the last tutorial. I should probably also mention, if you haven't seen the first sliding tutorial, I would probably watch that before watching this one. Right, let's get into it. Okay, so I'm going to discuss the changes I made to the initial sliding script to make this rotation possible. So the first thing you should note is when we have initiated the slide, one of the things I do is I disable humanoid auto rotate. This is because when you're in shift lock mode, normally when you turn the camera, that also rotates the character as well, the direction the character is facing. And we don't want that because we want to do the rotation ourselves. And so I set that to false when he initiates slide, and I set it back to true when he stops sliding. So when he stops sliding and he's still in shift lock mode, and he should be able to, it should resume the regular behavior of character facing in the direction of the camera. And so there's that. The other big changes have been made in this heartbeat function, and these are all new variables that were not there before. If you want to compare and contrast, I would look at the previous sliding tutorial and now. That will give you an idea of what changed. So this is different, and this is the same from the previous tutorial, but this is different because now we actually have to change the linear velocity slightly based on how the character rotated their camera. So let's talk about how this works. So the first thing you have to understand is that we get the speed that the camera has rotated. And the way we do that is we keep track of the current camera C frame and also the old camera C frame. The old camera C frame is the C frame of the camera on the previous frame. And at the end of each frame, we set the old camera C frame to be the current camera C frame. And if you want to know what the initial value of the old camera C frame is, it's just camera C frame. So initially, initially it's just current camera C frame, old camera C frame the same, but give it one frame and then they'll be different. So you have that. And so how do we know the degree to which because we have the C frame, but how do we know the angle in degrees that the camera rotated from right to left or left to right? The way we do that is we use the camera's right vector. So because we don't care about rotation vertically of the camera, the right vector is a good choice. What I mean by that is, think about it. When we're rotating this way, right, what axis is the camera rotating about? In this case, it's rotating about the right vector, right? Now, when I'm rotating this way, what vector is the camera rotating about? You can imagine the camera is rotating about its y-axis, right? So in this case, the right vector is rotating. Also, the forward vector is rotating. But then let's say that I have a top-down view of the character, and then I rotate. What vector is the camera rotating about? Well, it's rotating about its look vector, the forward vector. And that forward vector stays the same because I'm rotating about it. What the vectors are now moving are the right vector and the up vector. Those are rotating. So in either of these two cases, the right vector is always rotating. The one case where the right vector doesn't rotate is when we rotate about it, which is when we're rotating vertically. And we don't care about the vertical rotation of the camera. So that's why we're using the right vector here. Okay, so now you know we want to get the angle between the right vectors. So we use this vector 3 angle function to get that angle. But the thing is, we do not know the sine of that angle, right? Did we rotate 30 degrees to the left or did we rotate 30 degrees to the right? We do not know because it's simply the angle between the two vectors. It doesn't tell you anything about the direction of rotation. And so to make this, so normally when you call this angle function and you do not pass in the second parameter, it will give you back an unsigned angle. When I say unsigned, that means that the angle is always positive. It's simply the angle between the two vectors. But if you provide that second parameter, which is the axis, that determines the sine of the angle. Okay, and then you might be wondering, how does that determine the sine of the angle? Well, this is because I can only theorize about how the angle function is implemented. But what I assume is that Roblox does a cross product between the two vectors. And when you do a cross product, First of all, you should know that the cross product is not commutative. So when we search the order of these vectors, the sign changes. So anyways, when you do a cross product between two vectors, it gives you back another vector that is perpendicular to those two, right? So it's perpendicular to the plane that those two vectors lie on. And the cool thing about this is, depending on the order of the vectors, like whether you do old right vector cross current right vector or current right vector cross old right vector, that will determine the direction of this perpendicular vector, right? Because that perpendicular vector can either, it can be in two directions, right? I'm going to draw this in a second, but it can be in two directions, either pointing away or pointing into, while being perpendicular into the plane that these two vectors lie on. So it can either stick out of the plane that these two vectors lie on, or point inwards to that plane that these two vectors lie on. And so it gives you back a vector. So now we know that depending on, there's something called the cross product, the right hand rule, that determines which way this vector that it returns would point. But we can use that vector to determine the sign of the angle. But how do we know the sign of the angle? So the way we do so is by passing in a reference vector. And what I think Roblox does is, I believe it does a dot product between that cross product vector and this vector that you pass in. And based on whether or not that dot product is positive or negative, that would determine the angle. So I'm going to draw this. All right. So here's a little drawing. And as I was saying before, think about this blue vector as your right vector. And, think about the camera being somewhere here. So this is the right vector of the camera. And then you do, let's say, a 90-degree rotation of the camera in one frame, which is pretty fast, but it'll make this drawing easier. And so that right vector will end up where the purple vector is. And so recall I said that the cross product between these two vectors would give you the vector that's perpendicular to both vectors, or in other words, the vector that is perpendicular to the plane on which both of these vectors lie. And so this yellow square I drew here is that plane on which both of these vectors lie. And the result of that cross product is a vector that is perpendicular to the plane, but there are two vectors that are perpendicular to the plane. It could either be pointing up or it could be pointing down. And so and then also I should mention that which way that vector is pointing depends on how we rotate. Did we rotate from the blue vector to the purple vector? Or did we rotate from the purple vector to the blue vector? And again, there's something called the right hand rule, which you can use to determine which way that vector will point. So yeah, so once we have that vector though, we need to figure out whether it's pointing down or up. And the way we do that is we do a dot product against against the y-axis. And so recall that the dot product returns some number, right? And I always like to think about the dot product as just casting a shadow. So we look at the shadow that this red vector casts on the y-axis. And so in this case where it's pointing up, it's casting a positive shadow, you can say, on the y-axis. In the case where it's pointing down, opposite of this, if you think about that y vector is just pointing, starting from this green point right here, this red vector going down is pointing in the opposite direction. So it would be a negative shadow. So the dot product would return a positive number or a negative number based on the shadow that our red vector here, the vector that is perpendicular to the plane, casts on the y-axis. And that's how you can determine whether the angle is negative or not. So I'm just assuming that behind the scenes, the vector 3 angle function is doing something of that sort. Anyways, let's get back to Studio. So yes, and then we divide by delta time here because that's how much time has passed from one frame to the next. This is the same as before. And here I define this rot ease variable, and recall I want to make it so that if you are trying to rotate about on a steeper slope, it would be easier for you to do so. So this is just a measure of how steep the slope is. So recall the floor normal is the vector that's perpendicular to the slope. We take the dot product of that against the y-axis, and that will tell us how flat the slope is. And when there is maximum flatness, which means that the floor normal is the y-axis, so when we dot against the y-axis, it gives us back 1, then this would be 0. But we don't want it to be 0 because 0 would mean that we can't even rotate on flat ground. So I specified a minimum here so that we can at the very least still rotate a little bit on flat ground. So that's that variable. And then here's the rotation speed of the character himself. So that's simply the camera speed, and I've defined this variable called camera turn sensitivity, which defines how sensitive the character's rotation is relative to how fast you're moving the camera. So the higher it is, the more the character rotates when you rotate the camera. And here's where we have to shift the direction that the character is moving in slightly based on the rotation of the camera. So we take the floor normal and we're saying from axis angle. So this means that we want to rotate about the vector that's perpendicular to the floor. And we want to rotate by this amount. So it's the rotation speed times the rotation ease times delta time. So it should be able to rotate this much per second, right? I'm multiplying by delta time because that's how much, because that's how much we want, this is how much we want to rotate per frame. But over the course of a second, it would have rotated however much degrees this is. So if rot speed is like 30 degrees per second, over the course of 1 second, it would have rotated 30 degrees, you could think. But obviously that's modified by rot ease. So depending on how steep the slope is, that would determine ultimately how fast we will rotate. And then we just multiply that all by linear velocity, which is the original direction of the character. So we take the original direction vector that the character was going to move in, and then we rotate it using this C-frame about the floor normal. And here's our line orientation, same as the previous tutorial. We always align the character to the direction that he is moving. And here we set the old camera C-frame to be the current camera C-frame. And that is all. I can show this in action again. See? It's very satisfying to look at. Yes, I hope you enjoyed this tutorial. Don't forget to subscribe. And I do have a Discord channel now, and that is linked in the description. So if you are interested in speaking with like-minded individuals, and if you just have any questions in general, then feel free to join the Discord channel. But yeah, if you do enjoy the content, I would definitely subscribe if you want to see more content of this nature.